electronic device. So in this topic, I will discuss about the conductor, I will discuss about the insulator, I will discuss about the semiconductor, I'll discuss about the diode, the transistor. So let's move straight to electronic device. Electronic device is a device that allows small amount of charge to pass through them. Example, we have DVD, we have video CD, we have our radio, etc. So all these things I mentioned now are called electronic device. So they allow small amount of charges to pass through them. So from that, we'll be moving to what is called conductor, semiconductor, and what insulator. So conductor are material that allow electric current to pass through them. Conductor are material that allow electric current to pass through them. So they have high conductivity and low resistivity. So they have high conductivity and low resistivity. Meaning that, remember I said that they have what? High conductivity and what? Low resistivity. Then examples of conductor. Examples of conductor is all metals are conductor normally. All metals are conductor. That is the example. Example, copper, zinc, iron, sodium, etc. All metals, even transition elements, they are all conductors. So we now move to semiconductor. So semiconductor are material that sometimes they allow electric current to pass through them. Sometimes they do not allow. So it depends on some factors that will help electric current to pass through them. So meaning that their conductivity and resistivity lie between conductor and insulator. Example are the elements found in the group 4 of the periodic table. Example, silicon and germanium. We also have zinc selenide, zinc oxide, and etc. So, but now that is all about what? Conductor. So remember, sometimes they can allow, sometimes they do not allow electric current to pass through them. But I will still teach this topic in a elaborated form. So let's move, because of there is no time, let's move to insulator. Let's move to insulator. So insulator are material that do not allow electric current to pass through them. Remember, they do not allow. So example is plastic. Your plastic is an example. So they do not allow electric current to pass through them. Your plastic, your not only plastic, even block, dry wood, yes, they are all insulators. So, but before we understand the basis of an insulator, before we understand the basis, so which is the distinction between semiconductor, insulator, and conductor, the best way depends on the number. It depends on the number of electrons they have, which can be attracted in the conduction band. So this number of electrons, which I'm discussing now, that is why, but the numbers of what electrons. So it depends on the what number of what electron. So for instance, now we are going to use a theory called, which is the band theory. Is the best way which explain the difference between conductor, insulator, and semiconductor. Remember, for those writing JAMB WAEC, for the difference between semiconductors, insulator, and semiconductor, insulator, and conductor are best explained using what? Band theory. So in the band theory now, the band theory are made up of two gaps. Remember what I said? The band theory are being made up of two parts. So we have the conduction band. So here is the conduction band. So we have the valency band. So this is the valency band. This is the conduction band. So we have the valency band. We also have the conduction band. So we have the valency band supposed to be here. I mean the conduction band, then we have the valency band. So here now we have so again we have something like this. I'm coming, just have small patience. Then we have so meaning this is conductor, this is semiconductor, while this one is called what? Insulator. So as you are seeing this now, this is my conductor, so this is called insulator, while this one is called this one is called semiconductor, while the other one is called insulator. So if you look at the board now, you discover something. So this is conductor, semiconductor, and what? Insulator. So in conduction band now, in the valency band are called the valency band because they are made up of an individual valency electron. Why once we are talking about the valency band, so the gap between the valency band and conduction band, the gap between here and here and here and here and here are called energy gap. This is exam question, or energy gap, or you call it what? Valency gap. Are we there? So energy gap, or what? Or valency gap. So for instance now, we have conduction band, valency band. So remember, the valency band are made up of individual valency electrons. So this thing now are called the what? The band theory. Remember, this theory is called what? The band theory. So let's go to the band theory. For instance now, the conduction band and the valency band, the gap between them are called what? Energy gap or valency gap. Energy gap or valency gap. So the valency band are made up of electrons. Remember, they are made up of what? Electrons. So these electrons, they are made up of electrons. So this electron can move to the conduction band. It can move to the conduction band, meaning that whenever electron appear to the conduction band, remember, conductivity takes place. So whenever electron appear or move to the conduction band, meaning conductivity have occurred. So meaning that what you are having here now, for instance, in conductor now, so we now move to the explanation of the band theory. So in conductor now, there is no gap between the valency band and conduction band. When you look at it, you see there is no gap here. So but in semiconductor now, there is something like a small gap between the valency band and the conduction band. While in insulator, there is a big gap between the conduction band and the valency band. So in conductor now, electron can move from here to here without any obstruction. Electron can move from here to here, but there is no gap, so it can jump easily. So that is why they say that conductor conduct electricity or conduct electric current by what? Mobile electron. Remember, exam question. Conductor conduct electricity by what? Mobile electron. So then we now move to this thing. We now move to the semiconductor. So in the semiconductor now, there is a small gap between the valency band and the conduction band gap or band. So then what you are now going to do now, there is a gap between the valency and the conduction band. So what you are now going to do now is that, and you see that electron cannot jump easily from here to here. So what will now happen is that there is a factor that you are going to introduce called NTC, negative temperature coefficients. So the negative temperature coefficient happens that when this semiconductor are being heated, like if you heat its temperature, you discover that this electron here will be energized. It will absorb the energy. So when it is being energized, the electron will be moving around. So when the electron is moving around, if you apply a high temperature on it, so what will now happen is that electron will now jump from here to here. So when the electron jump from here to here, this one jump from here to here, it will create a hole. This one will now come here, then it will create a hole. So then electron from here will now jump again to here, it will create a hole. Electron from here will now jump to here, it will now create a hole. Then this one here will now come up. So that is why they say that semiconductor conducts electricity by electron and holes. Exam question. They conduct electricity by electron and holes. But why this thing happens is that by the application of what? Temperature. So without temperature, the semiconductor cannot conduct electricity. So but by the help of temperature, temperature will increase their conductivity. So then moving to wire in conductor. Wire in conductor, when you apply temperature in conductor, it will decrease their conductivity and increases their resistivity. So if we now move to insulator now, there is a big gap between the valency band and conduction band. Because of there is this big gap, so when we try to hit temperature here, so it will require for you to increase the temperature. So and trying to increase the temperature will damage the cell. That is why when you apply temperature on plastic, if or like heat, if you heat a plastic, before you know what is happening, the plastic will burn, or your polythene, which is your bag or anything, it will burn. Because of what? You have to increase the temperature before electron can jump from here to here. And trying to make the temperature to be high will damage the cell. So this is all about electronic device. I will revise it now. For instance, remember what I said? I said electronic device. Now we have three. For us to understand the basis of an electronic device, the theory we use is called the band theory. Remember the band theory. So this band theory are made up of the conduction band and the valency band. So the conduction band and valency band. So when the electron appear in the conduction band, conductivity takes place. So, but the valency band which we are having here, the valency band are made up of individual valency electron. So they are made up of individual valency electron. So meaning that electrons are always found in the valency band. So for conductor now, conductor did not have any gap, so electron can move from here to here without any obstruction. That is why they say that conductor conducts electricity by mobile electron. But for semiconductor, there is a little gap. So because of there is a little gap, you have to heat it temperature before electron can jump from here to here. And heating it temperature, then before you know what is happening, the electron here will be energized. That is, when it is being energized, then electron will now jump from this valency band to the conduction band by creating a hole. That is why I say that conductor conducts electricity by mobile. Semiconductor conducts electricity by holes and what? Electrons. So that is all about the semiconductor. But it can only conduct electricity by the application of what? Temperature. And the bond which you are going to see in this semiconductor are called covalent bond. Remember, exam question. Bond you are going to see there are called what? Covalent bond. So, but the only way it can conduct electricity is by what? Valence is by what? NTC, which is negative temperature coefficient. You have to adopt it. So adopting it means that you are going to heat this thing so that it can be able to conduct what? Electricity. But for this one, increasing in temperature will do what? Damage the cell, insulator. So from this, we are now going to move to a topic called semiconductor. So we now move to a topic called semiconductor. So semiconductor are the elements. For instance, if this is my periodic table, So this is my periodic table. So we have group 1, group 2, group 3, group 4, group 5, 6, 7, 0. So in this group now, we have first one carbon, we have germanium, then we have silicon. So these elements here are called the semiconductor. The elements found in group 4 of the periodic table are called semiconductor. And the elements are called silicon and what? Germanium. So silicon and germanium, they are called the semiconductor. And the bond found here are called covalent what? Bond. So the bond that exists between silicon or germanium are called what? Covalent bond. So now, remember I say that semiconductor are elements that are found in group 4 of the periodic table. And I have also given the definition of semiconductor from our former topic from the beginning. So I have already said it. So I will just go straight. So in semiconductor, I have been classified into two. So we have, in semiconductor, they are being classified into two. We have intrinsic semiconductor. Then we have two extrinsic semiconductor. So semiconductor. So in intrinsic semiconductor, remember I said there are two types of semiconductor: intrinsic semiconductor and what? Extrinsic semiconductor. So in intrinsic semiconductor, they are pure. They are always pure. Meaning that for this one, number of electrons, I will still draw the periodic table. So intrinsic semiconductor. So in intrinsic semiconductor, they are pure. That is what you need to know here. Number of electron is equal to the number of holes. Number of electron is equal to the number of holes. Then, but in extrinsic semiconductor, so semiconductor, they are not pure. So for you to make them pure, you this thing, for you to make them pure. So for you to make them pure, you adopt a process called doping. So you adopt a process which means doping. Doping means addition of an impurities to a semiconductor in order to increase their conductivity. Doping means, remember, for JAMB, those people writing JAMB, WAEC and to CME, doping means what? Addition of impurities to a semiconductor in order to increase their conductivity. In order to increase their what? Conductivity. So the remember I say that doping is what? The addition of impurities to a semiconductor in order to increase their conductivity. So the intrinsic semiconductor are divided into two. So remember we have the p-type and the what? We have the p-type, and what? N-type. So we have the p-type and the what? N-type. So we are going to now move to the what? P-type. So we are now going to move to the what? P-type. So for instance, if this thing is my periodic table, I mean sp orbitals. 4, 5. sp orbitals. This is my periodic table, which is the sp orbitals. So remember I said before that what? Semiconductor are found in the what? Group what? 4. This is my group 4. 1, 2, 3, 4, 5, 6, 7, 0. So here we have silicon, we have germanium. And remember, For any element that appear in group 4 has 4 valency electron in their atomos shell. So if an element that appear in group 3, meaning they have 3 electrons in their atomos shell. So in duping now, for instance, we have, because we are talking about the p-type. P-type. So in the p-type now, p-type semiconductor are produced by adding a trivalent element, that is element in group 4 of the periodic table, to a semiconductor. Remember, p-type semiconductor are formed by adding elements, which is element in this group 3 of the periodic table. These elements in the group 3 of the periodic table are called trivalent elements. They can also be called trivalent elements. Exam question. They can be called trivalent elements. So the trivalent element, by acronym, this trivalent element, I'll use BAJIT as the acronym, which is what? BAJIT. So for you to remember it in your exam, BAJIT. So in this BAJIT, B is for boron, B is for boron, A is for aluminium, G is for gallium, I is for indium, while T is for thallium. So T is for what? Thallium. Remember what I said, that T is for thallium. Then, if you look at the board now, then for instance now, we are having something like this. Here now is my semiconductor. Okay, here is my trivalent elements. I'm having 3 electrons, because trivalent elements have 3 electrons in their atomos shell. Example, aluminium, which is 283. 283, all of them. Even boron is 23, which is 5. So here now, so I'm having 1, 2, 3, which is trivalent elements. Trivalent elements. Remember, the acronym is what? BAJIT, from what I said, BAJIT. Then I'll add, here now is my semiconductor, which have how many electrons in the atomos shell? 4. So what will now happen here is that I'm going to add this electron here to the semiconductor. So adding the electron there to the semiconductor, adding this electron there to the semiconductor is called duping, which is the addition of an impurities to a semiconductor in order to increase their conductivity. So meaning that if I add electron here, this one will come here. If I add this one here, it will come here. If I add this one here, it will come here. So you discover that after adding the 3 electrons, there are still 1 electron remaining. So there are still 1 electron remaining, so that all of them will be double. So because of that, the p-type semiconductor are called acceptor. The p-type are called acceptor. And because of there is a gap here now, still there is a gap remaining, holes are the majority carrier, while electron are the minority carrier. Remember, holes are the majority carrier, while electron are the minority carrier. For instance, here now, I have this one, then remember what I said. Remember what I said. You can add this electron here now. If you add this electron here, you see something like this. You add this one, you see something like then this one here. So you discover that there are still 1 gap remaining to make it 8. Are we there? So there are still a gap here remaining. So that is why I say that holes are the majority carrier because of that, while electron are the minority carrier because the electron is not complete. The electron is not complete. Are we there? So, and remember, meaning that if they ask you in any exam that when you add boron to a semiconductor, which type of semiconductor are being formed? You say p-type. If they add aluminium to a semiconductor, which type are being formed? P-type. If they add gallium to a semiconductor, which type are being formed? p-type. If they add indium to a semiconductor, which type are being formed, which is the same thing, p-type. Then thallium to a semiconductor, which type are being formed, the same thing. Are we there? So from this now, we now move to n-type semiconductor. Are we there? We now move to n-type semiconductor. So the n-type semiconductor, you discover this is my n-type. N-type semiconductor are formed by adding a pentavalent element. Pentavalent means element in group 5 of the periodic table to a semiconductor. By adding a pentavalent element in group 5 of the periodic table to a semiconductor. Element in the periodic table to what? A semiconductor. So meaning that now, for instance, if you're having something like this, I can forward, okay, this is my p-type, and by acronym, the p-type semiconductor are called NEPA. Remember, this one is called gadgets, from what we said before. Why this one are called NEPA? NEPA. So meaning, this NEPA means any I means nitrogen. Any I means nitrogen. P means phosphorus. This first A means arsenic. While the second A means antimony. Then the B means bismuth. Remember again, N means nitrogen. Then P means phosphorus. A means aluminum, arsenic, and what? Bismuth by acronym. Meaning that if they ask you in exam, when nitrogen are being added to a semiconductor, which type are formed? N-type. When phosphorus are added to a semiconductor, which type are being formed? N-type. When aluminum are added to a semiconductor, which type are being formed? P-type. Sorry, when arsenic, not aluminum. Aluminum means P-type. When arsenic is added to a semiconductor, which type are formed? N-type. When antimony are added, which type? N-type. When bismuth are added, which type? The N-type. Are we there? So that is why I say NEPA by acronym. It is called what? The NEPA. So here now you discover when one electron is moved from here to here, you see something here, this one here, this one here, this one here. Then, so after adding the 4 electrons, there are still electrons remaining here in this n-type semiconductor. There are still electron remaining. That is why they say that the n-type semiconductor, n-type, remember, the electron are the majority carrier, meaning the electrons are more bigger, while the holes are the minority carrier. The electron are the majority carrier, while the holes are the what? Minority carrier. So they are called donors, and the n-type semiconductor are called donors. Why? Because after adding the electron here, you discover that there are still electrons still remaining here. So after adding it, there are still electrons remaining here. So that is why they are called what? Donors. Because we have 1, 2, 3, 4, 5. So here, then 1, 2, 3, 4. So if you add 4, it's still 4 from here. It still remains 1 here. So that is why I say that the electron are the majority carrier, while the holes are the what? Minority carrier. So from this now, we now move to application of what? A semiconductor. But before that, I would like to ask a question that will help us to understand this topic very well. Remember, I say this one is gadgets, remember, and this one is what? NEPA, which is a pentavalent element. So this is the N-type. So when you add boron and nitrogen to a semiconductor, which type are formed? The answer there is what? The P-type and the what? N-type, because boron forms the P-type, then why nitrogen forms the N-type. Then when you add boron and aluminum to a semiconductor, which type are formed? P-type and P-type, because boron is there, aluminum is there. But when you add boron and bismuth to a semiconductor, which type are formed? The type is what? The P-type and the what? N-type. Then when you add this thing, bismuth and what? Boron to a semiconductor, which type are formed? The N-type and the what? P-type, because bismuth is here. Always remember. So when you add arsenic to a semiconductor, which type are formed, which is the what? N type. And remember, the N type are called the electron and the majority carrier, while the holes are the minority carrier. While in P type, holes are the majority carrier, while electron are the what? Minority carrier. So we now move to we are going to move to application of a semiconductor. But this question that I just asked you people here, you still see it in JAMB. Like when I'm done, or you can solve everything in JAMB concerning this topic. I'll still do other videos. But what you are going to do is for you to subscribe to my YouTube channel. Like everything you want is there. After teaching the topic, just understand it very well, because the topic is very, very explanative. So far you understood it very well. Go to the past question. I will still solve the past question, because everything is there. Like all this question, everything I just said is there. So we now move to